Assalamualaikum. My name is Muhammad Faizul Kanaim bin Muhammad Hussaini. My metric number is B0819103992. Today I will explain about Lab 4 Continuous Signal Representation of Fourier Transform. I will explain for this lab. Okay, this is the coding that we must copy and type at MATLAB. So this is the coding that I copy from the question from the lab 4. So this is the coding. This lab this question asks to use 10 seconds and 5 seconds as input for first pass and second pass. So the first pass we add 10 seconds and the second pass 5 seconds. Okay, this is the graph for the coding. So this is the first pass graph and this is the second pass graph. And for this is a frequency spectrum for first pass graph, and this is the frequency spectrum for second pass. So you can see here the graph is different, and this is the graph for first pass and the second pass. So that's all from me. Thank you.
Hi, Assalamualaikum. My name is Fahmi bin Saadun from BET Section 1/2. Today I am going to do Lab 4, which is Continuous Signal Representation of Fourier Transform. So I am going to explain about the question and discussion, number 1 and number 2. So for number 1, we need to define Fourier transform. The Fourier transform is a mathematical function that takes a time-based pattern as input and determines the overall cycle offset, rotation speed, and strength for every possible cycle in the given pattern. It applies to waveforms which are basically a function of time-space or some other variable. The Fourier transform decomposes a waveform into a sinusoid and thus provides another way to represent a waveform. For number 2, we need to write down the general function for, there are two questions, which is for rectangular function and for sin C function. So for rectangular function, this is the general function, and this graph represents the output of the function. For sin C function, there are two questions in question B, which is unnormalized sin CT and normalized sin CT. So for unnormalized sin CT, this is the answer, the general function. Sin t equal to sin t over t. For normalized sin CT, this is the general function, which is sin CT equal to sin pi t over pi t. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name Haris Hakimi Ben Heri. So I will explain the question number 3. And that question is draw the graph manually rectangular pulse for FT and GT and also their frequency spectra. So the first graph at the left top of the left. So this is the rectangular pulse. I zoom it. So rectangular pulse t equals to 10, and then when we calculate for the frequency spectra, so we get the first graph that's not complete, and then this is the final graph, the frequency spectral graph final. And then at the question number 4, discuss your finding based on your result. Try to relate with the time scaling property. So to me, on the upper left row is a graph of the pulse function of unit ft, and below is the Fourier f omega transformation frequency function omega. So translation is a delay in the time domain is the interpret as a complex phase shift in the frequency domain. And the upper right row shows GT, the pulse of the delay units, next to the real and imaginary part of Fourier transformation. The Fourier transformation pass a function in a eigenvalue for a translation group. The imaginary part omega is RE8 because the negative sign exponential has been used in the Fourier transformation, which is a default as it originates in the Fourier series, but the sign is not essential for the transformation that will not be reserved. So for the last one, the conclusion. So what we learned is we were able to show the signal representation of Fourier transformation using MATLAB. The Fourier transform is a mathematical technique that transforms a function of time xt to a function of frequency x omega, which is closely related to the Fourier series. Thank you.